Okay, last example is example 8.4, a floodlight of mass 20 kg. This is our floodlight in a park is supported at the end of 10 kilogram horizontal beam. This is our horizontal beam. Mass of the beam is 10 kilogram that is hinged to a pole as shown in figure 8.7. A cable with an angle 30 helps to support the light. First, sketch the free body diagram and then determine tension and determine the force exerted on the beam by the pole. Then, first, what we need to do is find the CG. CG is the length of the beam. The length of the beam is start from here to here is length of the beam. The length is not given, means that we just label it as L. Then L divided by 2 is equal to 0.5 L. Then we assume 0.5, which is half of the length, is around here. Then this is our CG, means that this is our width of the beam. Okay. Second, just sketch the forces that acting on this beam. For next force is tension. Then also we have here width of the floodlight. After we sketch, then we draw the free body diagram. To draw free body diagram, you need to draw the beam. And then we have at the center, which is we have WB, and then we have width here, width F, and then we have tension here, which is T. For this floodlight become balanced, there is one force at the end of the hinge that we call it as supported force S. This S come from the normal force from the hinge, and then we have another force which is friction at the upward direction. Then the resultant between two forces, we have supported force there. Okay, for free body diagram, no need to write the force, friction force and normal force there. Just write the supported force, which is the resultant force. Okay, then this is our free body diagram for the beam. Next, determine tension in the cable. Okay, to determine tension to the cable, we have here 30 degree. Okay, first we need to find the pivot point, because we need to use second condition, which is total torque AC equal to total torque C. Whenever we use torque, we need to find pivot point. Pivot at point, you can label and choose any point to be pivot point. Here we have at this end, which is I label it as O, or you can pivot at the center, which is CG, or the end of the beam, which is at the WF. For me, I choose pivot at point O, because for force at supported force means that torque over there is 0, become axis of rotation. Okay, at pivot at point O, then we have here the distance, perpendicular distance from axis of rotation to WB is dB, which is dB is equal to 0.5 L. And then from axis of rotation here to force F, also perpendicular, means that this is our DF. Another one is torque at this point, from the axis of rotation to this force. If we want to use D, we need to find the perpendicular force, which is we must resolve this T. Then here T is equal to T sine theta, which is theta is 30 degree. Then we will have here perpendicular distance D for tension T. Then next we need to find the direction of the force will rotate. From the axis of rotation, for the first force, here we have WB, then our perpendicular distance is DB, then force B, it will rotate like this, which is clockwise. Also same goes to this one, from axis of rotation to second force, here we have D here, DF, perpendicular distance, then the forces we rotate also clockwise. Then lastly, force at T here, perpendicular distance is DT, then we have T here, we rotate anti-clockwise. Then we have WB will rotate clockwise direction, also goes to WF, also we rotate clockwise in direction, and then T here we rotate anti-clockwise. Then when we rearrange our torque here, total torque AC, we just have only one torque, which is torque T equal to, clockwise we have 2, which is torque B plus torque F. Then as we know that torque is equal to FD when F and D is perpendicular. Okay, then torque for T, F is T sine theta, D is DT, which is DT is length of this beam, which is L, equal to torque B is WB, the D is 0.5 L, plus torque F is WF, also length is L. Then T sine theta L also equal to WB is mass beam times G times 0.5 L, plus WF is mass of floodlight times G times L. Okay, from here we can cancel the L. Then T sine 30 is equal to mass of the beam is given, which is 10 kilogram. 10 times 9.81 times 0.5 plus mass of the floodlight is 20 times 9.81. Then you will get the answer for T. The answer for T is equal to 490.5 Newton. Okay, next questions B2, which is determine the force exerted on the beam by the pole. Means that these questions need me to find the force exerted at this force, which is S. We need to find S. Before we find S, we know that S is the resultant from this force, which is normal, or we can also write as x, which is resolving for S for component X, then S for component Y. Then we need to find Sx and Sy to find S, which is force exerted on the beam by the pole. Then here we use the first condition, which is total Fx equal to 0 and total Fy equal to 0. And also for T, we can resolve for two component, which is T sine theta, and also for T cos theta. Then here, find the force that exerted on X axis. We have only two, which is Sx minus T cos theta equal to 0. Then Sx is equal to T cos theta, which is T is from the calculation before, we get T is equal to 490.5 cos 30. Then we have Sx is equal to 424.79 Newton. Then find the Sx, then find Fy, which is total Fy equal to 0. Total Fy, we have T sine theta and Sy. Then Sy plus T sine theta equal to WB plus WF. Then we need to find Sy. Then Sy is equal to WB plus WF minus T sine theta. WP is MBG plus MFG minus T sine theta. Substitute the value of MB. MB is mass of the beam is 10 kilo times 9.81 plus mass of light is 20 times 9.81 minus T is again 490.5 sine 30. Then we will get Sy is equal to, and we calculate Sy, we will get the value is 49.05 Newton. After that, to find the resultant of Sx power of 2 plus Sy power of 2 set, and we will get Sx is 424.79 plus 49.05 power of 2, then set the value. We will get the answer for S is equal to 427.61 Newton. Then the direction of S we can also find, which is using tangent theta equal to Sy over Sx. Sy is 49.05 divided to 4.75. Shift tangent, then we will get theta is equal to 6.59 degree. Then when we draw the diagram, this is Sx, this is our Sy, means that this is our S, which is this is our theta 6.5 degree, which is above positive X axis. That is our direction of S.